Hello everyone, this is VIJAY math faculty. Heartily welcome to my channel Vedic Brilliant Math Educator. This is the first video of POLYCET. Today onwards I am going to teach POLYCET special program. In this program I will cover all topics basic level to high standard level with short tricks. Follow regularly, you are getting good rank in POLYCET. Keep on watching, don't skip the video till the end. That will definitely helpful for you. If you are watching first time of my video, just subscribe the channel and try to share this video to your friends and POLYCET aspirants. If you need of previous videos, just you can click this I button as well as you can go with playlist also. In this video, I would like to explain chapter number 1, real numbers. Before going to our topic real numbers, see some basic concepts. So this is our topic real numbers. So see the some concepts. So first one it is digits. So what are digits? 0 to 9. 0 to 9 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9. 0 to 9 are called digits. 0 to 9 are called digits. Here 0 is insignificant digit and 1 to 9 are called significant digits. Here 0 is the insignificant digit. 1 to 9 are called significant digits. Next one it is numbers. What are numbers? 2 or more than 2 digits are called numbers. For example, if you can take 10, in this 0 is the one digit, 1 is one more digit. Here we have the 2 digits. 2 or more than 2 means you can take 1 not 3 you have to take. Here 3 is the one digit, 0 is the one digit and 1 is the one more digit. Here it is the 3 digit number. So 2 or more than 2 digits are called numbers. So here we need to take, so 10 to so on are called numbers. Next, natural numbers. This already you know you learnt in basic concepts, you learnt in 10th class only. Natural numbers. What are natural numbers? The counting numbers like 1, 2, 3, 4 so on are called natural numbers. What are natural numbers? The counting numbers like 1, 2, 3 so on are called natural numbers. It is denoted by capital N. So N equal 1, 2, 3 so on. This is called natural numbers. Next, whole numbers. So what are whole numbers? Whole numbers. What are whole numbers? We are including 0 to the natural number. We are including to 0 to the natural numbers are called whole numbers. Means it is W equal to, W we are denoting as a W we are denoting whole numbers. W equal to 0, 1, 2, 3 so on are called whole numbers. Here we are included to the natural number. 0 is included to the natural numbers. Means we need to write in the set 0, we are getting the whole numbers. 0 to if it is starting. So natural number set is from 1 to start. Whole number set it is starts with 0. Next, integers. What are integers? The positive and negative including 0. The positive values, negative values including 0 are called integers. It is denoted by Z or I. So most of the times we are using Z only. That equal -3, -2, -1, 0, 1, 2, 3 so on. These are called integers. So the positive values, negative values including 0 are called integers. Integers are denoted by Z. Z equals so on -3, -2, -1, 0, 1, 2, 3 so on. Next, rational numbers. What are rational numbers? The numbers which we can write in the form of P by Q. Which we can write in the form of P by Q. Q not equal to 0 are called rational numbers. So what are rational numbers? The numbers which we can write in the form of P by Q. Here Q not equal, the denominator must be not equal to 0 are called rational numbers. It is denoted by Q. Rational numbers are two types. One is terminating decimals, and one more is non-terminating and not repeating decimals. Sorry, repeating decimals. Non-terminating and repeating decimals. So terminating decimals and non-terminating and repeating decimals. For example, 1 by 2. 1 by 2 value we are getting 0.5. It is the terminating decimal only. So 0 is the 5. So terminating means we are getting the remainder will be 0. Remainder will be 0 means it is terminating decimal. Otherwise we can say the denominator is of the form 2 power n into 5 power n. 2 power n into 5 power n means the denominator is of the form 2 power n into 5 power n means it is the terminating decimals. So here terminating means remainder must be 0. Next, non-terminating and repeating decimals. For example, 1 by 3. So you can take 3, 0 the 3 3s are 9. 1 remained. Already it is point 0. 3 3s are 9. Again 1 remained. Point it is 0. 3 3s are 9. Means that digit is repeating. So 0.333 so on, it is like that it is getting. So non-terminating and repeating, it is not getting the remainder 0, and the digits decimal places in the digits are repeating. Like that one we have to say non-terminating and repeating decimals. So this is the rational numbers. Now it is irrational numbers. Irrational numbers. So what are irrational numbers? The numbers which we cannot write in the form of P by Q, Q not equal to 0. Otherwise, non-terminating and not repeating decimals are called non-terminating and non-repeating decimals are called irrational numbers. For example, once again repeating the irrational numbers. The numbers which we cannot write in the form of P by Q, we can't write in the form of P by Q and Q not equal to 0 are called irrational numbers. Otherwise, non-terminating and non-repeating, not repeating decimals are called irrational numbers. For example, pi value, pi equal to 1.4142, so on it is not repeating, that like that one we can say the non-terminating and non-repeating decimals. So like that one we can say the irrational number. Here pi is the irrational number. So it is denoting as Q dash or S. S also we are denoting. Q dash or S. Some key points are there. What are the key points? Means the rational numbers between any two rational numbers. The rational numbers between the rational numbers between, for example, a and b equal to a plus b by 2, we need to use the formula. The rational numbers between a and b equal to a plus b by 2. The irrational numbers between a and b, the irrational numbers between a and b equal root ab. So here rational numbers means we need to take a plus b by 2, and irrational numbers means a and b. Irrational numbers means we need to take root ab. Now one is here neither prime or composite number. Third one is neither prime nor composite. So what are the prime numbers, what are the composite numbers, we will discuss next. And here 2 is only one, that is 2 is the even prime number. Even prime number. This is about the rational and irrational numbers. So our topic, it is real numbers. What are real numbers? The combination of all numbers are called real numbers. So what is real number means? Natural number set and whole number set, integers and z, rational numbers, and it is the irrational numbers. This union of this all set are called real number set, that is denoted by capital R. What we have to discuss here, that all are basic concepts of real numbers. Now our textbook real numbers, in first one it is Euclid's division lemma, EDL, Euclid's division lemma or division algorithm. What is division lemma or division algorithm? Given positive integers a and b, any two positive integers a and b, given positive integers a and b, there exists unique pair of integers q and r. Q and r, unique pair of integers q and r satisfying a equal bq plus r, here 0 less than or equal r less than b. This remainder r value always lesser than the b. 0 less than or equal r less than b. So here one example, for example 7 by 3 it is. So 7 by 3 means 7 by 3, how we have to write it? 3 to the 6, one remainder. Means for EDL, B means 3 into 2, divisor into quotient plus remainder. So this is the division EDL, Euclid division algorithm. Given positive integers a and b, there exists a unique pair of integers q and r satisfying a equal to bq plus r, 0 less than or equal to r less than b, is called Euclid division algorithm, Euclid division lemma or division algorithm. Next one it is fundamental theorem of arithmetic. Fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Every composite number can be expressed as a product of primes, and the prime factorization is unique apart from the order in which the prime factorization occurs. So that means, for example, you can take the one number that is 210 you have to take. How we have to write the prime factors? 2 10s are 20, 2 5s are. Again 5 table 2, 5 1s are 5 2s are 5 1s are 3 7s are. So you can write 2 into 5 into 3 into 7, you have to write it, or this one only you can write 2 into 7 into 3 into 5. You have to write any order, it is correct only. So what is the fundamental theorem of arithmetic? Every composite number can be expressed as a product of primes, and the prime factorization is unique apart from the order in which the prime factor occurs. This is called fundamental theorem of arithmetic. One more statement it is. This is the statement only, theorem statement. Let P divides A square. Let P divides P is a prime number. If P divides A square, then P divides A. If P is a prime number, P divides A square, then P divides A. So P divides A square, then P divides A. Some concepts are there, ones that rational combination of rational numbers and irrational numbers, that combination. So here the statement it is, if P is a prime number, P divides A square, then P divides A. These statements we are using in the problems. That's why only I am explaining this all. Notes. First one it is, sum of two irrational numbers need not be a irrational. So sum of two irrational numbers need not be a irrational number. What does that mean? So sum of two irrational numbers, any two irrational numbers you have to take, means root a plus root b. It is need not be a irrational number they given. So for example, a value 2 I am taking, b value minus 2 I am taking. So root 2 minus root 2, that value is 0. 0 is not the irrational number, it is the rational number. So the sum of two irrational numbers need not be the irrational, means it is the, sometimes we can get rational also. Next, the product of two irrational numbers need not be a irrational. Need not be a irrational. Means here product means multiplication we need to take. So any two irrational numbers I am taking now, root 5 into root 2. Root 5 into root 2 we are getting root 10. So root 10 is the irrational number. But what is given here? The product of two rational numbers need not be a irrational, it is given. So the product of two irrational numbers, so it is the irrational I got. Now root 5 into root 5, root 5 into root 5, root 25, that value is 5. So 5 is the rational number, means it is not the irrational. The product of two irrational numbers need not be a irrational. Need not be a irrational means it is not the irrational number. Next one more, the product of rational and irrational. The product of rational and irrational always, the product of rational and irrational always irrational. The difference and the sum of rational and irrational always irrational. What is logarithm? So if a power x equal to n, then x equal to log n to the base a. Here this base we are transposing to right. So we are taking the log. So where a greater than 0, a not equal to 1, a not equal 1, n greater than 0, and a comma n belongs to R. A comma n belongs to R is called logarithm. So what is logarithm? If a power x equal to n, then x equal to log n to the base a. Here condition a greater than 0 and a not equal 1. A value is greater than 0 and not equal to 1, and n greater than 0 and a comma n belongs to R is called logarithm. So some properties of the logarithm. So laws of logarithms. So what is the laws of logarithms? First one is product rule. What is the product rule? Log x base a, log xy base a equal to log x base a plus log y base a is called product rule or first rule. That is log xy base a equal to log x base a plus log y base a is called product rule or first rule. Next quotient. Quotient rule. What is quotient rule? Log x by y base a equal to log x base a minus log y base a. Quotient rule is log xy base a equal to log x base a minus log y base a. Next, power rule. What is power? Log x power m base a equal m log x base a. Log x power m base a equal m log x base a. So this is the laws of logarithms. So here in a logarithm, it is two types. It is logs are two types: natural logarithm and common logarithm. What is natural logarithm? What is common logarithm? So natural logarithm, common logarithm. Common logarithm in we are taking as a base e, we are taking base 10, we are taking. So common logarithm we are taking a base as a 10 we can take, that is called common logarithm. In the natural logarithm, the base we are taking as a e we can take, that is called natural logarithms. So up to here common logarithms only we are discussing about the common logarithms. Now we will discuss some problems. These are the old concepts of the real numbers. These concepts you are learning, you are perfect in the concepts. Problems will be very, very dead easy. Let us see some concepts of the problems. Let us see the problems on basic concepts. The number of prime factors of 36 is. So how many prime factors are there we need to find. So first you have to write the prime factors. 2 18 the 36, 2 9 the 18, and 3 3 the 9. How many number of prime factors we have here? 2 and 3. Only we have 2. Option C. Next one. Which of the following is an irrational number? Which is the irrational number? So 12 into 3. 12 3 is the 36. Root 36 value, it is 6. Means 6 is the rational number, not the option. 32 into 2. 32 2 is the 64. Root 64, it is the 8. 8 means it is the rational number. Next, option C. 35 plus 14. 35 plus 14, it is 49. Root 49 value is 7. It is also not the rational. Sorry, it is not the irrational. Means it is the rational. 25 plus 16. 25 plus 16, that is 41. Root 41. We do not have the root for the 41. So option D. Here what they asked, Which of the following as a irrational number? So root 41 is the irrational number. That option we need to write. Next, third one. What is the LCM of greatest 2-digit number and greatest 3-digit number? The LCM of 2-digit number, greatest 2-digit number and greatest 3-digit number. So what is the greatest 2-digit number? 99 and 3-digit number is 999. Now we can take 9 table I am taking. 9 11 the 99, 9 ones are 9 ones are 9 ones are. 11 table 2 it is not possible. So we can write 9 into 11 into 111. 111 only we need to write. So what is the LCM of 99 and 999? That is 9 into 11 into 9 into 11 into 111. Means option D is correct. Next, fourth question. What is the HCF of A and A plus 1? Where A is a natural number. Where A is a natural number. So here HCF of A and A plus 1. A and A plus 1. A and A plus 1 means it is, for example, if we can take A value is 1, 1 comma 1 plus 1 means it is 2. 1 comma 2. 1 comma 2 means that is the consecutive numbers. The HCF of any two consecutive numbers value is 1. So means the HCF is 1. B we are getting. So here it is given A comma A plus 1. A comma A plus 1 means they given the consecutive numbers it is given. Consecutives of any two natural numbers, any two numbers is 1 only. The HCF of any two consecutive numbers, HCF is 1. Next, if A and B are two co-primes, then their LCM is co-primes. What are co-primes? The HCF of two numbers is 1 is called, that is co-primes. So they do not have the common factors. They do not have the common factors. For example, you can take 2 and 3, two numbers you have to take. So here 1 and 1 into 2 we can write prime factors, 1 into 3 we can write. So only 1 as a common factor. Only 1 as a common factor. Other than 1, there is no any common factor. Means the like that one we can say the co-prime numbers. So what are the co-prime numbers? The HCF of two numbers is, one is called co-prime numbers. Otherwise, 1 as a common factors of both numbers is called co-prime numbers. So here what is our question? If A and B are two co-primes, then their LCM is, LCM we need to find. So what we have to get the LCM? So here A comma B are two co-primes. For example, here you can take 2 and 3, LCM we have to take 2 and 3 here. We are getting product only we are getting. 2 3s are 6 only we are getting. They do not have the common factors. We have the common factors, we can take that one. We do not have the common factors means the product only we can get the LCM. If any two co-primes, the LCM is the product only. The product of two numbers only we are getting the LCM. So if A and B are two co-primes, then their LCM is A into B. Product we have to take. Next, if X and Y are co-primes, then HCF of X square and Y square. Here what is given? X and Y are co-primes is given. Co-primes, any two co-primes you have to take. I took 4 and 5 I took. So 4 and 5 only one as a common factor. X square and H square. H square means 16 and it is 25. So 16 prime factors how we can write it? 2 into 2 into 2 into 2. 25, 5 into 5 we can write. We do not have the common factor for both numbers. So 1 as a common factor means the HCF of X square and Y square we can get 1. Means option C is correct. Once again repeating. If X and Y are co-primes. Co-primes means only one as a common factor for both numbers. only 1 as a common factor for both numbers. I took here 4 and 5 I took. So that one means, not that one means we can take 2 and 3 also. So we do not have the common factor. So 2, how we can write it? 1 into 2, 3 equal 1 into 3 only we can write. So 1 as a common factor. 1 as a common factor for both numbers. Like that one we can say the co-prime numbers. But here x square and y square, HCF of x square. X square means 4 and 9. 4 how we have to write it? 1 into 2 into 2 we can write. 9 we can write 1 into 3 into 3. Only here we have the 1 as a common factor. Here we got only 1 as a common factor. Means if x and y are co-primes, then the HCF of x square and y square is, we are getting 1. Next, seventh one. If 123 by 125 is a dash decimal, so we can take like this method. We can't do, we are getting or not, how we have to check it. So we have the theorem, we have that theorem we need to apply. The denominator is of the form 2 power n into 5 power n, means it is terminating, otherwise it is non-terminating and repeating. So once you can check the denominator, 125, 5 2s are 5 5s are 5 5s are, means we can write, so that denominator we can write 5 cube we can write. So here 2 means 2 power 0. So 2 power n into 5 power n means it is terminating decimal. A, option A. So the denominator is of the form 2 power n into 5 power n, means it is terminating, otherwise it is non-terminating. Next questions. 8th one. If 7 power x plus 3 equal 5 power x plus 3, then the value of x. So here it is given 7 power x plus 3 equal 5 power x plus 3. So if we can do some process, we are getting very lengthy, we are getting, it will take much more time. So here options are given, we have the options, we can choose the options, we can get within fraction of seconds we are getting that answer. Okay, see that. First we have to d value 0 you can substitute. So 7 power 0 plus 3 means 7 power 3 equal 0 plus 3 means 3. So 7 power 3 not equal 5 power 3. Next, c equal to 0, 2 you can substitute. So 7, 2 plus 3 that is 5 equal 5 power 2 plus 3 5. It is also not equal. Here 3 you can substitute. 7 power 6 we are getting, 5 power 6 we are getting. It is also not the correct. Next, a value minus 3 you can substitute. 7 power minus 3 plus 3 equal 5 power minus 3 plus 3. Minus 3 plus 3 plus 3 minus 3. Means 7 power 0 equal 5 power 0. We have the identity. What that identity? A power 0 equal 1. Means 7 power 0 equal 1. 5 power 0 equal 1. Both sides we got the equal answer. Means option A is correct. Minus 3 is the answer. Next, if HCF of A comma B is 12 and A into B is 1200, the LCM of A comma B. So we have the formula, the product of two numbers equal product of two numbers equal LCM into HCF. Product of two numbers it is given here A and B. So A and B product it is given by 1200. And LCM of two numbers we need to find LCM only. L into HCF. HCF how much? HCF of two numbers is 12. 12 on the 1200. So LCM equal to 100. LCM how much here? 100. We do not have the option. So it is maybe 100. So option C. So here option, I changed the option. Here we do not have the actually option. So C, I took 100. Next, identify a prime number among the following. So prime number means one and itself only factors are called prime numbers. Only it is having two factors. So 576 means 1 table to possible, 2 table to possible, and 3 table to, like that it is. Means we are getting more than 2 factors we are getting. Means it is not the prime number. 675 means 1 table to it is possible. Here last digit 5. Last digit 5 means 5 table to it is possible. And this number only it is possible. Means more than 2 means it is also not. Next 3200. 3200 means 1 table to possible, 2 table to possible, 10 table to possible, 100 table to possible. So we are getting more than 2 factors. More than 2 factors means it is not a prime number. Means which one is remained? That one only a prime number. Means option C is the prime number. So here this is the about basic concepts. So in the next video we will focus on some medium and standard level problems we have to discuss. When you will practice more and more, you are getting good rank in POLYCET. I hope you are enjoyed this session and this session is very helpful for you. Don't forget like and comment. We will meet in the next video. This is Vijay Kumar signing out. Thank you very much.